Hello, this is Mr. Manley, and this is an introduction to vectors. A vector is a directed line segment. That's the way it's described, and it just means that I want to have a way of labeling these different segments that have both a direction as well as a length. And these are two of the elements that we would be looking for when we're examining a vector are the direction, we actually call it a direction angle, and the magnitude. The magnitude is going to be the length of the vector, and the direction angle is going to be its direction relative to the xy axis. Now say I've got 2 points that determine a vector. Like I've got these 2 points here, 0.23 and 0.68. We'll graph those. So I'll just kind of do a rough graph here that I've got say 0.23 here on this xy axis, and I've got 0.68 here, up here to the right. Now it's not enough that I have those 2 points because remember it's a direction. We need to have a direction with a vector. So I would have to indicate that the vector is not only these 2 points, but that it is from one point to another. So I'm just going to put the word to between those, and that'll make us a nice vector there. So I'm going to go from 2, 3 to 6, 8, and I'm going to indicate that with an arrow. And there's the vector. Now something that we do with vector is we write the vector, put the vector in standard position, and that is we move the vector to the origin. So if I did that with this vector, I'm going to use this marker here because there's going to be some overlap. So that would be the vector in its standard position. Now, that's the visual of the vector. The notation that we use to talk about the vector really looks like the coordinates of the endpoint in standard position. So what are the coordinates? What are the coordinates of this endpoint of this vector that is in standard position? Maybe you could see that if I'm going from 2 to 6, that's going to be 4 units to the right. So that's going to be these 4 units. If I look at the picture, these 4 units here. And then when I go from 3 to 8, I'm going to be going up 5 units. And that'll be the vertical movement of this vector in standard position. And so there's the notation. The notation is 4, 5. It looks like the coordinates of a point, right? But we have these this notation with these brackets that are kind of look like less than or greater than signs. Okay, coming back to our list over here on the right, the direction angle, the magnitude, and I'm going to add one more thing. I'm going to add the word component form. So up here, find some space for that. Component form. So these are some fundamental vector vocabulary, the component form. All right, so with this vector that we're talking about so far, this is the component form. So that 4, 5, that's the component form of the vector. And the magnitude of the vector is going to be the length of this side. So this length right here, that's going to be the magnitude of the vector. Well, that's easy enough using the Pythagorean theorem, right? If I use the Pythagorean theorem, I could say that the magnitude, and we're going to have a special notation for that. Let's give you a couple of notation points here. One is that vectors are often referred to as vector v, vector u, vector w, vector q. So it's a variable, right? And these are just some of the common ones, v, u, and w. Another thing is that we might sometimes have this little arrow above the letter, but we don't have to. So I could just have a v, and that's that means vector v, or I could put a little arrow above it, and that helps us indicate that it's a vector. So that's one notation thing. Another notation thing is that this magnitude that I'm talking about finding, so we're talking about finding the magnitude, that the notation to indicate that I'm talking about magnitude is the vector variable, and then we have these bars that are indicating magnitude. Okay, so the magnitude of this vector is the square root of, and we're going to have the two sides, right? So it's just going to be 4 squared plus 5 squared. That's 25 plus 16. So the magnitude of the vector is 41. And if we're kind of treating this as a checklist, what do we have? We did the magnitude. If you look to the right here, where I have them listed out, we did the magnitude, we did component form. Now, the other thing is we'd want to find the direction angle. And the direction angle is going to be here. Now, the direction angle for this one, so you see where I'm putting the theta here in that triangle that we have drawn. Let's just look at another example. If I had, I'm going to put another xy axis here. If I had a vector that in standard form came out like this, okay, the direction angle would be here. So the direction angle is identified and measured in the same way that we measure angles on a unit circle. It's from the positive x-axis. Okay? So finding this direction angle theta, I'll do that in the lower left-hand corner here. Theta is equal to the arctangent of, and then I have the two sides, right? So the vertical side there was 5, and the horizontal side is 4. I don't have that drawn very well, huh? The vertical side looks shorter than the horizontal side, but it's supposed to be longer, right? Yeah, the vertical side is supposed to be 5, and the horizontal side is supposed to be 4. All right, so arctangent 504, and that's whatever the calculator key in is. I can leave that to you. All right, now if we did this vector down, look back down to the right side here, if I wanted to find that direction angle for that vector, this theta, I'm going to piece it together, right? So I'm going to say that I have 180 degrees. You see me drawing 180 degrees. And then I can use a little trigonometry, arctangent, to find the rest of it, and I'll do a sum and get that direction angle. Okay? So do we want to look at another direction angle? I suppose we could. I'll take another vector. All right, so here's another vector, and I'm going to graph it. And that'll be, I'll try and do my scale a little bit more carefully this time. 1, 2, 3, 4. 1, 2, 3. And then I'll draw the vector right there. Okay, now this vector has a magnitude, which we can easily calculate with the Pythagorean theorem. Vector v equal to the square root of 4 squared plus 3 squared. So that's square root of 25. Oh, that was a 3, 4, 5 triangle, huh? Okay, so we've got a magnitude of 5, and then I want the direction angle. And the direction angle is going to be here. That's the direction angle theta. So how am I going to do that? I'm going to do arctangent. I'm going to say it like this. Theta, if you look down in the left-hand corner, theta is equal to 180 minus the arctangent of, it's opposite over adjacent, so that's 3 over 4. You see that? And we can do that calculator key in for arctangent 3 over 4, 180 minus. I'm going to go ahead and do that. And I get theta is equal to 143.1 degrees. Now I want to show you something with this vector now that I've got the direction angle and I've got the magnitude. we've got this vector, vector v, which is negative 3, 4. Now, I just want to show you two more notations for this. One is that we can write it like this, negative 4i plus 3j. It's just whatever the components of the vector are. The horizontal component I place with I, and the vertical component I place with j. And there's a whole piece to this where we can talk about I being the unit vector. What would that be? It would be the unit vector 0, 1, and j is understood to be the unit vector 1, 0. But that's going to get into some detail that I don't want to get into on this video, and I'm kind of running out of time. I just want to show you the one more way to write a vector is with its magnitude, which in this case is 5, and then I'm going to say cosine of the direction angle, and then sine of the direction angle. Kind of running out of space, but hopefully you can read that. So these are three different ways of writing a vector. We have this this form of the vector, we have this form of the vector, and we have this form of the vector. And the big thing to understand is that they all mean the same thing, right? They all mean, if I go back to an xy axis, what all three of those mean is this. It means that vector. We didn't get into vector operations here, addition and subtraction of vectors, and I think that's about the only other topic I would have wanted to cover. So if you need help with that, see me, or if you don't have me in for an instructor, see your instructor, or maybe look for somebody else's video.